Previously, we talked about the supremum of A and B and their relationship if A is just a subset of B. This video will talk about infimum. Infimum is the greatest upper bound of any set. Let's prove that if the infimum of A and infimum of B exist for A being a subset of B, then the infimum of A is greater than or equal to the infimum of B. Here is its statement that A and B be subsets of the set of real numbers, with A being subset of B. If the infimum of A and infimum of B exists, then the infimum of A is greater than or equal to the infimum of B. This means that the greatest upper bound of A is greater than or equal to the greatest upper bound of B, even if A is just a subset of B. Here is the proof here. Okay. We will start by letting A and B be subsets of the set of real numbers, with A being subset of B. Okay. In an illustration, we could come up with this here. If this is set B, A could be just a subset of A. Of course, it could also be equal to B because of this notation, but in this case, generally, A is a subset of B. Okay, now, let us also introduce the infimum of A. Now, let us introduce infimum of B being equal to M. Okay, because it should exist based on the definition. Let M be infimum of B. In short, this is the greatest lower bound of set B. So if M is the greatest lower bound of B, so M could be an element here. Okay, so we could have that. This would mean then M is less than or equal to B for all B element of set B, because this is the greatest lower bound. So in short, it is less than all the elements of that set, or even equal, because it could also represent what is the really the smallest element of that set. So that's why it's less than or equal to that. Okay? Now, let us also talk about set A being a subset of B. Since A is a subset of B, every element, okay, of A, element of A, is also in B. This is per definition of a subset, because whatever elements you can think of A here, it's just still an element of B. Now, what is the implication of this? This follows that our M earlier, being the infimum of B, okay, is still less than or equal to all A element of A. This is because if this is already the greatest lower bound of B, and all elements of A are also element of B, so in short, this should also be less than or equal the elements of A, because there can be no other element. Let's say there is an element here that is even lesser than that. If M is already the least upper bound of B, okay, there can be no element in A here. Okay, which means that M is also a lower bound. This is what I mentioned, because M is smaller than all the elements of A. Let me change my pen color to black. So again, this is M. Whatever the element here, this is still lesser than that. So, which means that M is also a lower bound for A. Okay? Now, since we have established that M, being the infimum of B, is the least upper bound of set B, which is also the least upper bound of set A, now we can look into the two possible cases, whether this M is just an element of B but not of A, or whether or not this M is also an element of A, since we have here the equality symbol. So here are the two cases. If M is an element of A, okay, this means that if we have an M is equal to the infimum of A because infimum of A exists per our assumption. Though I have not placed here the assumption here, but since this is part of the statement, so infimum of A is just equal to M. This means that M, if M is an element of A, this is also equal to the infimum of A, being the least upper bound of A. Okay, next scenario. If M is not an element of A. In short, it's just an element of B, but it's not part of A. And take note that M is the least upper bound of both sets. Then, M is less than infimum of A. In short, if an infimum of A exists in A, and since M is not an element of A and it's the greatest lower bound of A and B, whatever would be this infimum of A, this is still larger than M because M, again, is the greatest lower bound of both. So hopefully that's clear. Now, if we are to combine them, thus M being infimum of B is less than or equal to the infimum of A. Combine these two scenarios where M is an element of A and M is not an element of A but the element of B. Now hence, or therefore, the infimum of B is less than or equal to the infimum of A. Or let me structure it like this because this is what we would like to prove. Okay, we can simply interchange them. We can now say, hence, using this proof, the infimum of A is greater than or equal to the infimum of B because of these two scenarios. In short, the greatest lower bound of A, that's infimum of A, is greater than or equal to the greatest lower bound of B, depending in these two scenarios based on this proof if A is a subset of B. Thank you very much for watching.